Good morning. Today we're looking at section 6.3, critical points and extrema, functions with functions of two variables. The first concept we're looking at is that as a critical point, and in a multivariable function, that's a place where both the derivatives are zero. It's easier to see that looking at pictures. So I have the function from the first example, f of x equals x squared plus 2xy plus 3y squared minus 4x minus 3y, and that's this nice yellow surface. If I have h and k, I'm starting at 0, 0, and cutting the function. The red curve says I let x be 0, the blue curve says I let y be 0, and I look at the two functions, and as I can see, that can't possibly be the minimum. There's clearly a minimum on this function. That can't be it, because if I slice in either the x direction or the y direction, I don't have a minimum in one direction, let alone two. So what I'm going to do is play with it and just play with the point a bit and see till I get it where it looks like it's a minimum in both cases. I'm going to take it and turn it sideways and just play with it a bit. And by playing with it, I can get a place that I'm at the bottom of the parabola for both x and y. So I found a place where the derivative with respect to x is 0 and the derivative with respect to y is 0. That's a critical point. Those are the kind of points I want to look for. Now, normally we don't have something so nice that lets us play with the graph, and so we're going to want to go to other means. And the first mean we're going to do it is algebraic. I'm going to look at this same function, f of xy is equal to x squared plus 2xy plus 3y squared minus 4x minus 3y. Now I can take the derivative of that with respect to x. The derivative of x squared is 2x. If x is a variable and y is a constant, the derivative of 2xy is 2y. The derivative of 3y squared is 0. The derivative of minus 4x is minus 4. The derivative of minus 3y is 0. Similarly, I can take the derivative with respect to y of f, and I'll get 0 plus 2x plus 6y minus 3. And now I would like to have both of those equal to 0 at the same time. So I'm looking at trying to solve 2x plus 2y minus 4 equals 0, and 2x plus 6y minus 3 equals 0. Why I look at this and say, I'll do a good job if I subtract minus 4y minus 1 equals 0, y equals minus 1/4. I then plug that back in, 2x minus a half plus 4 equals 0. That solves for x equals 9/4, which is the same thing I got when I looked at the picture. So this lets me do it algebraically, and for this case, that's fairly simple. However, most of the people in the class, algebra hasn't been their friend, and we'd like to be able to use technology to say, how do I get Excel to find the solution of a system of equations for me? So I'm going to pull this off to the side, pull up Excel, and take what I've already done so far. I'm going to look at my formulas. I'd like to show the formulas, and notice I have x and y. The derivative of f with respect to x is 2x plus 2y minus 4. The derivative of f with respect to y was 2x plus 6y minus 3. And now I'd like to get Excel to figure out for me a place where they're both 0. I'm going to use my good old friend solver, and I need to be a bit more specific on this. I'd like to make this cell D2 equal to 0 while also having C2 equal to 0. And I want to be able to change A2 and B2. So I'm going to pull up solver. And with solver, we already have it filled in because I tried this in advance. So I'd like to change D2. I want to change it to make it a value 0. I'm going to have two inputs, A2 and B2, and subject to the constraint that C2 has to be 0. So I've put all of those in. Let me delete this constraint and add it back in. So I add that constraint by saying I want to add a constraint. My cell reference for my constraint is C2. I want that to be equal to 0. I'm going to say, that's okay, that's the constraint I want. Now I look at it and say, I'm ready to solve, and it's got an answer. Now when I look at the answer, solver got these almost to 0 by taking those places. I'm going to look at it and say, I think that's a fine answer, but I'd like to look at what happens if I have more exact numbers that seem to be in line with the kind of equation I have. And when I do that, my almost 0 becomes 0. So this now gives us 3 ways we found the critical points. One is looking at a graph and saying, I can spot it on the graph. The second one, I took the 2 partial derivatives and I algebraically computed the partial of f with respect to x and the partial of f with respect to y, and said, now I have a system of 2 equations and 2 unknowns. I can solve that algebraically, but it occurred to me I may find solving algebraically, if I don't have very nice functions, is something I'm going to want Excel to do. And so I used solver to say, I'd like to make dy 0 while keeping dx 0. So this gives me an idea of what critical points are. As with the single variable, critical points are going to be my candidate points, the places where I could have a maximum or minimum. In the next video, we're going to look at to see how you figure out if it is a maximum or minimum.